The Sensmet µDOES analyzer uses atomic emission spectroscopy to accurately measure metal concentrations in liquids. At the core of this process is a micro-sized plasma, generated at the tip of an electrode, producing an intense energy field. This plasma excites the metal ions in the solution, causing them to emit light at specific wavelengths. By analyzing this emitted light, we can precisely determine the concentrations of various metals. This groundbreaking technology paves the way for a new era in process control for hydrometallurgical applications.
Welcome, and thank you for joining the session today. We are excited to share valuable insights into Sensmet µDOES technology and its groundbreaking capabilities in the real-time analysis of metal concentrations in aqueous solutions. Today's presentation will address three main questions. First, why this technology is essential. Second, how it works with its unique approach. And third, how it benefits your specific operations. But before we dive in, let's just introduce ourselves.
So, hello everyone, I'm Toni Laurila, I'm the CEO of Sensmet. My background is in physics and I have been developing industrial analyzers for the past 20 years.
I am Aapo Roos, CSO of Sensmet, a physicist as well, with relatively extensive experience in advanced spectroscopical technologies. Together, we aim to bring you a clear understanding of µDOES technology and its impact on novel, robust, and efficient elemental analysis.
Before we start, I would like to remind that during the webinar session, you can change the side of the two windows you see, the presentation window and the video window. You can either track the line between the two windows, or you can hit the maximize button on the upper right-hand corner of the window to make it larger or smaller. Secondly, at the end of the webinar, we will have a session to answer your questions that you can send us over the chat. So please use the chat during the session to send your questions to us. We have today a great audience of nearly 100 participants. And now, before we actually launch the webinar, may I ask from which different countries are you joining us today? So please write us to the chat from which country are you from. So we have here Turkey, Switzerland, Finland, Japan, UK, Germany present, great, Poland, Belgium, Austria, Spain, France, Norway, Canada, Israel. Great, so we have truly international audience today, so welcome. So let's start.
At Sensmet, this question why defines our mission: to deliver a reliable solution that merges a scientific precision with practical usability and adaptability. With µDOES technology, we need the needs of the industries where fast, accurate data acquisition isn't just beneficial. It's essential for boosting process efficiency, reducing costs, and supporting processes of strategic importance.
Our µDOES technology was specifically developed to overcome the limitations of existing analytical techniques by offering a robust, low-maintenance solution that requires no hazardous reagents, no carrier gases, and ensures consistent accuracy across diverse sample matrices. This unique approach provides unmatched reliability and efficiency, making it the ideal choice for industries that depend on precise real-time elemental analysis to optimize their processes
Sensmet's µDOES technology offers data accuracy comparable to ICP-OES, the workhorse for metal concentration analysis in the laboratories. However, unlike traditional ICP and other laboratory methods, µDOES addresses the existing significant limitations. Laboratory methods are often too slow from the perspective of our clients who need rapid and actionable data. Automating measurements whenever possible is clearly advantageous. The cost of maintaining a 24/7 laboratory operations are substantial, with carrying expenses alone potentially reaching hundreds of thousands of euros annually, plus the burden of personnel costs. And additionally, finding qualified laboratory staff is increasingly challenging, particularly for facilities located far from major population centers.
Our goal is not to replace crucial laboratory measurements, but to reduce their frequency and associated costs. By doing so, we allow laboratories to focus on the most critical analysis while providing the benefits of continuous real-time monitoring. Real-time data brings immense value by providing an instant view on what's occurring within the process or sample matrix without delays. The image on the slide depicting a clear road ahead symbolizes the real-time insight µDOES provides. Real-time data allows us to see clearly ahead, understanding where the process is headed without lag. Sensmet's µDOES technology is 100% automated, requiring minimal consumables and maintenance, and making it an optimal solution for industries seeking efficiency, reliability, and uninterrupted operation.
Next, we will show a video demonstrating how our µDOES technology operates in practice. In this example, we analyze lithium in geothermal brines. Please pay close attention how the instrument functions and what it looks like, as this will be the only demo in this webinar. This video was filmed at Sensmet's customer application center, and it will give you a clear sense of our technology's performance and practical application.
We have prepared 3 synthetic geothermal brine samples. These samples, they are simulating a Central European geothermal brine with a dilution ratio 1:100. Each of the samples is containing approximately 320 ppm of sodium, 40 ppm of potassium, and magnesium 1.4 ppm. The lithium concentration in these samples is changing. Sample 1 has 0 ppm lithium, sample 2 0.2, and sample 3 2 ppm of lithium. This is demonstrating the changes of lithium concentration during DLE processes. The samples we have are there. We are already measuring the lithium concentration in the very first sample. We see that the lithium concentration is varying slightly around 0 ppb. Now Johanna is going to change the sample. Now we should have 0.2 ppm of a sample lithium. The sample is drawn through that sample line directly to our sample cell. The orange color, what we have there in the plasma, it is coming from sodium concentration. It's atomic emission spectroscopy. And what do we have here? We have a very nice concentrations around 0.2 ppm of lithium with this incredible fast measurement time of approximately 1 second. All right, let's go from 0.2 ppm up to 1 ppm. So the sample is thrown again with a sample pump to the sample cell. The sample cell volume is approximately 4 milliliters. So the response times are real quick, as we already see here on the screen. Going to measure around 2 ppm of lithium. The noise level is there higher than at 0.2 ppbs because the instrument, the noise level is always related to measured concentration. The lower the concentration, the more precise the instrument generally speaking. So very nice. We go back to 0. There we go. And soon we should have here the response time. Its next measurement, we go down 0.0. That's going to approach 0 in concentration. That is how a µDOES is working. We measure simultaneously all the concentration, lithium, sodium, potassium, magnesium in this brine sample. Well, that's it.
Now that we have explored why our online µDOES technology is essential, let's move on to how it works. In this section, we'll break down the core mechanisms behind our technology and explain what sets it apart from traditional analysis methods. You will see how we combine advanced optical and electronic systems to provide high precision, real-time elemental analysis with minimal operational complexity and maintenance. This will help you to understand why µDOES is both an innovative and practical solution for industries seeking efficient, accurate metal concentration analysis. So just like ICP-OES, the laboratory workhorse for metal measurements, µDOES is based on optical emission spectroscopy. This shared foundation allows us to achieve high accuracy and reliable data for metal concentration determination. Our process starts by generating an electrical discharge directly within the liquid sample at the tip of one electrode using high voltage pulses, so electricity. The controlled high voltage pulses create micro-sized plasmas within the liquid, reaching momentarily temperatures up to 10,000 degrees. The plasma excites metal atoms and ions in the sample, and as they return to their ground state, they emit light that contains the spectral signatures of the metals present in the liquid sample.
The emitted light is then transmitted through optical fibers to our spectrometers, where we measure the entire spectrum from 200 nanometers up to 840 nanometers. This broad spectral range enables us to detect and quantify metal elements, several metal elements simultaneously, ensuring comprehensive and precise analysis. Our technology can be described as a robust and simplified version of ICP. There are many similarities in the underlying principles. However, the core concept of µDOES is really very straightforward. And that simplicity comes with substantial advantages. Unlike traditional ICP-OES systems, µDOES eliminates the need for components that typically require significant maintenance. There is no spray chamber, no nebulizer, no coil for plasma generation. This minimalist approach reduces maintenance demands while maintaining measurement accuracy. Their simplicity truly is elegant. Another noteworthy feature is that µDOES does not require carrier gas. The measurement is conducted directly in the diluted sample, with the device automatically adjusting the sample's conductivity by adding a small amount of acid. Second, unlike ICP-OES, small particles do not interfere with the measurement. They simply pass through the sample cell without affecting the analysis. This makes microdust ideal for measuring dissolved metal concentrations in solutions, ensuring reliable and precise results without additional complexities. Due to these design advantages, sample preparation is much simpler compared to laboratory methods, making microdust highly suitable for online applications where continuous real-time monitoring is essential.
Let's take a look at another short video. In this clip, you will see the microdust analyzer's liquid-filled measurement cuvette, where we actually generate the micro-sized plasma. The cuvette holds approximately 4 milliliters of liquid, while the plasma itself is about 1 cubic millimeter in size, so it's a small plasma within the liquid. This demonstration will give you a clearer understanding of the unique and efficient design behind our technology. So what's really happening in the measurement cell. One key aspect to understand is that microdust is specifically designed to measure metal concentrations. On this slide, you see the metals highlighted in green that we have successfully measured using microdust technology, the dark green metals there. In the light green, you see the most recent additions for which we are currently developing applications such as rare earth element monitoring. It's likely that we can also measure the other metals shown now in gray, although we don't have yet experience with them. But this highlights the potential for extending our analytical capabilities as we continue to explore and validate new applications of our technology, so to cover all metals.
Now that we have covered why microdust technology is essential and how it works, let's shift to the most important question. How does it help you? In this section, we'll explore the practical benefits and real-world impact of implementing microdust technology. We'll show how it streamlines processes, reduces costs, and enhances the accuracy of metal concentration analysis in various applications. Could adaptive microdust drive more efficient operations and support better decision-making in your industry? On this slide, we highlight several esteemed clients with whom we have collaborated, showcasing the diverse ways our microdust technology can be applied. These world-class organizations have engaged with Sensmet for various projects and applications, demonstrating the versatility and potential of technology in addressing industry-specific challenges and advancing metal concentration analysis.
In a recent field trial conducted at a talc production plant in central Finland, Sensmet's continuous metals monitoring technology was deployed to evaluate its capabilities for environmental water quality monitoring. During this trial, a significant rainfall event occurred, which led to a rapid spike in the nickel concentration in the nearby river water, followed by a quick decrease. This fluctuation was revealed and clear correlation between the rainfall and the changes in nickel concentration levels detected, providing crucial insight into the environmental dynamics of metal dispersion. What made this discovery notable was the real-time nature of the data collection. Detecting such sudden and transient spikes in metal concentration would have been impossible using traditional laboratory analysis, which relies on periodic sample and time-consuming offline results. Continuous monitoring, as offered by Sensmet's µDOES, allowed for an immediate understanding of the rapid environmental changes, enabling more responsive and effective management strategies. While this example highlights the benefits in environmental monitoring, the same principles apply to process industries. Unexpected, previously undetected phenomena can occur at any time, and understanding these can be key to achieving smoother production processes. This translates to more consistent product quality and more efficient operations. Continuous real-time data empowers industries to adapt quickly, ensuring stability and enhancing control over complex systems. The environmental monitoring case here demonstrated not just the technological precision of µDOES, but also its practical value in revealing improvement opportunities that would have otherwise gone unnoticed. The new online capability supports both environmental sustainability and process optimization, underlining the significant potential of continuous method monitoring.
As we come to the end of this session, I want to highlight key takeaways. Sensmet µDOES technology represents a significant leap forward in the field of real-time metal concentration analysis. We have shown why this technology is essential, how it works, how it can benefit you and your industry. By providing a robust, automated, and precise solution, µDOES simplifies analysis, reduces operational costs, and reveals insights that would otherwise remain hidden with traditional methods. Whether applied to environmental monitoring or integrated into industrial processes, µDOES empowers users with reliable real-time data. So this leads to better informed decision, more stable process operations, and higher product quality. Our technology supports a future where precision and efficiency go hand in hand, helping you to optimize processes, reduce waste, and achieve better outcomes. Thank you for your attention, participation today. We look forward partnering with you on your journey towards more efficient, data-driven, and sustainable practices. If you have any questions or would like to discuss potential applications further, we are here to help.